of condensing and absorbing carbon and nitrogen by their surface. May not the effect of the solid and fluid excrements, which are the ashes of plants and grains, which have undergone combustion in the bodies of animals and of man, be dependent upon in the same cause? Should not the fertility resulting from their application be altogether independent of the ammonia they contain? Would not their effect be precisely the same in promoting the fertility of cultivated plants, if we had evaporated the urine and dried and burned the solid excrements? Surely the cerealia and leguminous plants which we cultivate must derive their carbon and nitrogen from the same source whence the gramineae and leguminous plants of the meadow obtain them. No doubt can be entertained of their capability to do so. In Virginia, upon the lowest calculation, 22 pounds weight of nitrogen were taken on the average yearly from every morgen of the wheat fields. This would amount in 100 years to 2200 pounds weight. If this were derived from the soil, every morgen of it must have contained the equivalent of 110,000 pound weight of animal excrements, assuming the latter, when dried at the temperature of boiling water, to contain 2%. In Hungary, as I remarked in a former letter, tobacco and wheat have been grown upon the same field for centuries without any supply of nitrogenised manure. Is it possible that the nitrogen essential to and entering into the composition of these crops could have been drawn from the soil? Every year renews the foliage and fruits of our forests of beech, oak, and chestnuts. The leaves, the acorns, the chestnuts are rich in nitrogen. So are coconuts, breadfruit, and other tropical productions. This nitrogen is not supplied by man. Can it indeed be derived from any other source than the atmosphere? In whatever form the nitrogen supplied to plants may be contained in the atmosphere, in whatever state it may be when absorbed from the atmosphere, it must have been derived. Did not the fields of Virginia receive their nitrogen from the same source as the wild plants? Is the supply of nitrogen in the excrement of animals quite a matter of indifference? Or do we receive back from our fields a quantity of the elements of blood corresponding to this supply? The researches of Boussingault have solved this problem in the most satisfactory manner. If, in his grand experiments, the manure which he gave to his fields was in the same state, in other words, dried at 110 degrees in a vacuum, as it was when analyzed, these fields received in 16 years 1,300 pounds of nitrogen. But we know that by drying all the nitrogen escapes which is contained in solid animal excrements, as volatile carbonate of ammonia. In this calculation, the nitrogen of the urine, which by decomposition is converted into carbonate of ammonia, has not been included. If we suppose it amounted to half as much as that in the dried excrements, this would make the quantity of nitrogen supplied to the fields 1,950 pounds. In 10 years, however, as we have seen, only 1,517 pounds of nitrogen was contained in their produce of grain, straw, roots, etc. That is, far less than was supplied in the manure. And in the same period, the same extent of surface of good meadow land, 1 hectare equals 1 Hessian morgen, which received no nitrogen in manure, 2,062 pounds of nitrogen. It is well known that in Egypt, from the deficiency of wood, the excrement of animals is dried and forms the principal fuel, and that the nitrogen from the soot of this excrement was, for many centuries, imported into Europe in the form of sal ammoniac, until a method of manufacturing this substance was discovered at the end of the last century by Gravenhorst of Brunswick. The fields in the delta of the Nile are supplied with no other animal manures than the ashes of the burnt excrements, and yet they have been proverbially fertile from a period earlier than the first dawn of history, and that fertility continues to the present day as admirable as it was in the earliest times. These fields receive every year from the inundation of the Nile a new soil, in its mud deposited over their surface, rich in those mineral elements which have been withdrawn by the crops of the previous harvest. The mud of the Nile contains as little nitrogen as the mud derived from the Alps of Switzerland, which fertilizes our fields after the inundations of the Rhine. If this fertilized mud owed its property to nitrogenized matters, what enormous beds of animals and vegetables, excavae and remains, ought to exist in the mountains of Africa, in heights extending beyond the limits of perpetual snow, where no bird, no animal finds food from the absence of all vegetation. Abundant evidence to support of the important truth we are discussing may be derived from other well-known facts. Thus, the trade of Holland in cheese may be adduced in proof and illustration thereof. We know that cheese is derived from the plants which serve as food for cows. The meadowlands of Holland derive the nitrogen of cheese from the same source as with us, i.e., the atmosphere. The milch cows of Holland remain day and night on the grazing grounds, and therefore, in their fluid and solid excrements, return directly to the soil all the salts and earthy elements of their food. A very insignificant quantity only is exported in cheese. The fertility of these meadows can therefore be as little impaired as our own fields, to which we restore all the elements of the soil as manure, which have been withdrawn in the crops. The only difference is, in Holland they remain on the field, whilst we collect them at home and carry them from time to time to the fields. The nitrogen of the fluid and solid excrements of cows is derived from the meadow plants which received it from the atmosphere. The nitrogen of the cheese also must be drawn from the same source. The meadows of Holland have, in the lapse of centuries, produced millions of hundredweights of cheese. Thousands of hundredweights are annually exported, and yet the productiveness of the meadows is in no way diminished, although they never receive more nitrogen than they originally contained. Nothing can be more certain than the fact that an exportation of nitrogenized products does not exhaust the fertility of a country, inasmuch as it is not the soil, but the atmosphere, which furnishes its vegetation with nitrogen. It follows, consequently, that we cannot increase the fertility of our fields by supply of nitrogenized manure or by salts of ammonia, but rather that their produce increases or diminishes in direct ratio with the supply of mineral elements capable of assimilation. The formation of the constituent elements of blood, that is, of the nitrogenized principles in our cultivated plants, depends upon the presence of inorganic matters in the soil, without which no nitrogen can be assimilated, even when there is a most abundant supply. The ammonia contained in animal excrements exercises a favorable effect, inasmuch as it is accompanied by the other substances necessary to accomplish this transition into the elements of the blood. If we supply ammonia associated with all the conditions necessary to its assimilation, it ministers to the nourishment of the plants. But if this artificial supply is not given, they can derive all the needed nitrogen from the atmosphere, a source every loss from which is restored by the decomposition of the bodies of dead animals and the decay of plants. Ammonia certainly favors and accelerates the growth of plants in all soils wherein all the conditions of its assimilation are united, but it is altogether without effect as respects the production of the elements of blood. Where any of these conditions are wanting, we can suppose that asparagine, the active constituent of asparagus, the mucilaginous root of the marshmallow, the nitrogenized and sulphurous ingredients of mustard seeds, and of all cruciferous plants, may originate without the aid of the mineral elements of the soil. But if the principle of those vegetables which serve as food could be generated without the co-operation of the mineral elements of blood, without potash, soda, phosphate of lime, they would be useless to us and to herbivorous